This lab report is on the Lines of Charge Physics 2 lab. This lab will use a more accurate model to calculate the electric charge from a piece of tape than the previous lab. The purpose of this lab is to observe the difference between a point charge model and a line charge model. And the results will show that the net charge of the tape using a line charge model must be greater than what we estimated last week or a couple weeks ago with the point charge model. The surroundings is basically everything that is not the top tape that's in the surroundings. So that's the bottom tape, the air in my hands, also the earth, I suppose, and the system is the top tape. So we're assuming some things about the initial conditions, that the tape is neutral before we charge it. The base tape we use to charge it is also neutral. The hanging tape is only affected by gravity and our charged tape that we hold under it. And we assume that each U-tape has about the same amount of charge evenly distributed along the length of the tape. So this is the model that we create using Python. And note that the green arrows and the white and yellow arrows both have two very different scalars. So don't pay attention to the relative size between the yellow and white arrows and the green arrows. That was just so had to scale them to fit everything on the screen. But the green arrows are the electric field that the top tape is experiencing. The white arrows, the electric force vector the top tape is experiencing. The yellow arrows, the gravitational force that the top tape is experiencing, and the red and blue lines are the top and bottom tape, respectively. So we had to measure the gravity, which we did using F equals mg. And on our first experiment we did a few weeks ago, we found that the electric charge on the tape was 2.2 to the negative 8 coulombs, but using our new model we found this is wrong because it results in a force of gravity significantly larger than electric force. So in our new model we found that the electric force is actually 3.8 times 10 to the negative 8 coulombs, and we found that just by adjusting it until the arrows were equal in magnitude. So the way that the code works is we use 10 point charges to represent each tape. The electric force on the top tape is the sum of forces from each point charge on the bottom tape on each point charge in the top tape. So to implement this, we use nested for loops because we need to, for each point charge in top tape, we need to consider how each point charge in bottom tape affects it. So possible sources of error are that we are only using 10 points to represent this line, when in reality it is closer to an infinite number of infinitely small points along this line. And if we modeled each of the tapes as a single point charge like we did in the previous lab, we would have found a smaller charge on the tapes, and I already discussed that a few weeks ago in our previous lab. So why do these estimates differ? Because in a point charge model we are not considering the ways in which all the points of charge along the tape interact with each other. The line charge model is more likely to be closer to reality because the tape is not a single point charge, it has a length, and the charge is along that length. In conclusion, the magnitude of the charge was 3.8 times 10 to the negative 8 coulombs. The point charge model and line charge model give different results, and the point charge model will result in an underestimation of the magnitude of charge.